The next set of identities that you're going to be introduced to are the Pythagorean identities. So again, these are listed underneath the basic identities and they're right here. So what it is that sine squared x plus cos squared x equals 1. There's a whole explanation about why this is an identity and how it was derived, and it's in the textbook. But I'm just going to leave it as that and say that there are 3 other forms of this trig identity as well, this Pythagorean identity, that you get by firstly taking this equation and dividing by sine squared x. So if you divide every single term by sine squared x, you get this form of it. Or if you take every single term and divide by cos squared x, you get this form of the Pythagorean identity. All right, so let's look at them in action. So this first expression, we want to simplify. Now, everything's already in sines and cosines, so the only thing I can do is expand. So I'm going to distribute the 1 through the second bracket. I get 1 times 1 is 1. 1 times negative sine x is negative sine x. Sine x times 1 is plus sine x, and then sine x times negative sine x would be negative sine squared x. Okay, so where would I go next? Well, I've got 1 minus sine x plus sine x. So the minus sine x plus sine x would go away, and I'd be left with 1 minus sine squared x. Now, up until now, you would have said, hey, that's fully simplified. Everything's in sines and cosines. But what we're going to be able to do is change from a binomial expression to a monomial expression. So this is your Pythagorean identity, sine squared x plus cos squared x equals 1, but you can also use this in different forms. For example, if I rearranged the equation and I subtracted sine squared x from both sides of the equation, I would end up with cos squared x is equal to 1 minus sine squared x. So I can now replace the 1 minus sine squared x with cos squared x. And this is going to seem weird at first, but you'll just get used to identifying them. So anytime I see a 1 and a squared trig function, I am right away drawn to like, ooh, is this a Pythagorean identity? All right, so you could pause the video and give this one a try. Hopefully you paused it and you're coming back. So the first thing I'm going to do is realize that this entire binomial is getting squared. So you cannot distribute the squared because it's actually the entire bracket that's getting squared, which means times by itself. So I'm going to write it as 1 plus tan x times 1 plus tan x. So 1 plus 1, or 1 times 1 is 1. 1 times tan x is tan x. And then I'm going to distribute the tan x. Tan x times 1 is tan x. And tan x times tan x is tan squared x. Now I could simplify. You can simplify a couple things. Hopefully that thing I said about noticing a 1 and a squared trig identity starts triggering your head to think about Pythagorean identities. So I'm going to rearrange this to write it as 1 plus tan squared x. So again, the commutative property of addition says that I can write this as 1 plus tan x plus tan squared x, or I can write it as 1 plus tan squared x. It won't make a difference. And then I have 2 tan x's, so plus 2 tan x. And then I'm going to recognize that this is a Pythagorean identity. 1 plus tan squared x is equal to secant squared x. So I'm going to replace my binomial with a simpler monomial, and I'm going to leave it like that, plus 2 tan x. Now, some of you might be going like, well, Karen, why don't you, replace the secant squared x with a 1 over cos squared x and the tan x with a sine x over cos x? Sure, my answer to all of these are, how do you know when to stop? I'm going to say that I would stop there, but if you had a right side of an equation and it had coses and sines, then yeah, you could go further. You could change them. But for now, we're going to call that good. All right, the next thing you have to learn how to do is factor trigonometric expressions. So this is just like factoring that you've done in any other course, except now instead of having just x's or just variables, we're going to have trig functions. So the first type of factoring we're going to review is greatest common factoring. So hopefully with this binomial, you notice that these two terms have something in common, and that something is sine x. So I'm going to greatest common factor out a sine x. So if I pull that sine x out front, sine squared x divided by sine x is sine x, and then sine x cos x divided by sine x would be just a cos x. So that is greatest common factoring. The next type of factoring that you should be aware of is difference of squares. So you should notice that this is a difference of two perfect squares. to factor a difference of squares, I draw two brackets, and you're going to draw them bigger than you normally would. And then you take the square root of the first term and you write it first. So the square root of sine squared x is just a sine x, and I write it first. Because it's a difference of squares, one bracket's going to get a plus, the other one's going to get a minus, and then the square root of cos squared x is just cos x, and we're going to write it last, and it's done. All right, the last type of factoring is one that if you aren't coming from Math 50, you might not have done very much. So it's called sum or difference of cubes, and it won't come up very often. And I'll talk you through how to do it. So what I do is I draw a smaller bracket and then as big a bracket as I can fit in this page. Okay, so to factor a sum or difference of cubes, the first few steps are the same regardless. You take the cubed root of the first term, so the cubed root of 1 is 1. The cubed root of 125 is 5, and the cubed root of tan cubed s is tan s. Now here's where it gets weird. To fill in the second bracket, I'm going to do the following. I'm going to go square, so I'm going to square the first term. So 1 squared is 1. And then I'm going to multiply the two terms together. So I'm going to take 1 times 5 tan s, and I'm going to write it in the middle. So I'm going to go like this, and I'm going to go 1 times 5 tan s is just 5 tan s. So that was multiply. I'll put that in orange so it matches. Okay, and then we're going to square again. So we're going to go from here, and we're going to square that last term. And so we've got 5 tan s that I'm going to square. So 5 squared is 25. And tan s all squared is tan squared s. Okay, hopefully you can read that. So first step, small bracket, cubed root, cubed root. Second step is to fill in the second bracket. You square the first term, you multiply the two terms together, and then you square the last term. Okay, then we have to fill in the signs, and we fill in the signs using SOAP. SOAP stands for same. So the first sign in the first bracket is the same of whatever the expression is. So since it's a difference of cubes, you're going to put a minus. And then the second letter is an O, which stands for opposite. So the next sign is going to be opposite this one. So if the first one's a minus, you're going to put a plus. And then lastly, always positive. So the last sign that goes in here is always positive. So this last term's always positive. So what we've done is we've factored a difference of cubes, right? If I were to multiply this back out, then I would end up back here. And it's the only way that you can get this expression. If this is new to you, please contact and ask for more practice. You know, I'd probably start giving you ones from Math 11 with just X's and Y's, and then we could build up to putting some trig in it. All right, moving on to the last type of factoring that we're going to cover, so I'm just tripping over my words, which is factoring trinomials. So when you're factoring a trinomial, it's that whole idea of doing the AC method. If you look at this trinomial, it's different than this trinomial. So with this trinomial, you have a 1 in front. So if you're comfortable with factoring and you're comfortable factoring with sines and cosines in there, you could notice that because there's a 1 out front, that the only two things that are going to multiply to get you that first term are sine x times sine x. Okay, now what we're trying to do is figure out what numbers multiply to give me positive 1 and add to give me negative 2. Well, the only two numbers that multiply to give me 1 are 1 and 1. And then to make them add to give me negative 2, they should be negative 1 and negative 1. Okay, so this factors to this, which if you wanted to, you could rewrite as sine x minus 1 all squared. If the sine x's are throwing you off, you can factor this using just a single variable and then replace back. So what that means is that you could rewrite this as u squared minus 2u plus 1 and factor it using u's. So you're just kind of taking out the part that's a trig, and then you'd have to put the sine x back in for u after. So now you'd put a sine x back in anywhere you had a u. So if you're not feeling comfortable factoring with the trig expression and this isn't making sense to you, just book some time, come in, get some help, send us an email, whatever it is that we can do for you. All right, last one. This one, I hope you never ever forget to greatest common factor first. So out of these three terms, I'm going to pull out a 2. So I'm going to greatest common factor out that 2, which means I'm going to write it out front. I'd be left with 2 sine squared x plus 5 sine x plus 3. All right, now this is one that I actually do have to do the AC method for because I have to figure out 2 things that multiply to give you 2 sine squared x and 2 things that multiply to give you 3. So what I'm going to do is the whole AC. So I'm going to do 2 times 3 is 6. I'm looking for 2 numbers that multiply to give me positive 6 and add to give me positive 5. So that's going to be positive 2 and positive 3. All right, so what do I do with that? Now I decompose that middle term. So I go 2 sine squared x plus 2 sine x plus 3 sine x plus 3. And then I'm going to factor by grouping. So out of this first group, I can take out a 2 sine x. The second group, I'm going to take a 3. So what am I going to be left with? Not a lot of room. Here we go. So out of the first group, I'm going to pull out a 2 sine x to be left with sine x plus 1. Out of this group, I'm going to pull out a 3 to be left with sine x plus 1. All right, now I'm going to greatest common factor. I have the greatest common factor of sine x plus 1 in both of these terms. So I end up with sine x plus 1 times 2 sine x plus 3. Again, if it's too overwhelming to factor with the word sine in there, feel free to write it as u. So factor 4u squared plus 10u plus 6. Do all the work, and then anywhere you have a u, just put a sine x in for it. Okay, so why are we learning how to factor? Well, the whole point of this chapter is simplifying. So now we're going to learn how to simplify by factoring. So if I look at this expression, hopefully you're starting to look at it and it's screaming at you that there's a common factor between these two terms. If you see it, it should be sine squared x that can come out of both of these terms. Okay, so if I pull out the sine squared x, what would I be left with? Well, for the first term, sine squared x divided by sine squared x is 1, so I'd be left with a cos squared x. And then sine to the 4x divided by sine squared x, I can subtract the exponents and I end up with sine squared x. Okay, well, how did that make it simpler? Hopefully you're starting to spot the Pythagorean identities. So even though on your page it's written as sine squared x plus cos squared x, commutative property of multiplication, they can be written in any order, but I can replace that with 1. So this is going to simplify to just sine squared x, which is way simpler. All right, so there's 3 more questions here to practice. Feel free to pause the video at any time when you feel like you've got it, but I'll just work through the rest of them and you pause when you want. All right, so what can I do with this one? So, maybe you kind of think this is a Pythagorean identity because there's a 1 and a squared term, except if I go back to the Pythagorean identities, if I were to rearrange this, it'd be 1 minus cos squared x equals sine squared x. So it's a bit off. You could change it the other way. You could go cos squared x minus 1 equals negative sine squared x, and you could definitely replace this with that. But what I notice is that there's a cos x minus 1 on the bottom, and that this is a difference of squares. So I'm going to factor that top as a difference of squares. I'm going to draw my 2 brackets, give myself lots of room to write, and I'm going to take the square root of the first term to get cos x, square root of 1 to get 1. 1 gets a plus, 1 gets a minus. Now my denominator is cos x minus 1. I'm only allowed to take the denominator binomial as long as I take all of it. Well, hopefully you recognize that this binomial is the same. And so now this would simplify to just cos x plus 1. Way simpler. Okay, keeping on going. Looking at this one, I noticed that in the top I could greatest common factor out a 2 secant x. I'd be left with 2 tan x plus 1. And if you want to do that work on the side because you're having a hard time seeing what you'd be left with, take this expression, write it down, divide by 2 secant x, and go from there. On the bottom, I can also take out a 2 secant x. I'd be left with 3 tan x plus 1. Ooh, that came out weird. Plus 1. Now, the only factor they have in common is the 2 secant x, so I can simplify those, and I'd be left with 2 tan x plus 1 all over 3 tan x plus 1. Now, even though there's some commonalities there, because this one has a 2 and this one has a 3, the binomials are not the same. You can't take any parts of them, so that is fully simplified. All right, last one. So on the top, I noticed 2 sine squared t plus sine t minus 3, so I'm seeing a trinomial. So I'm going to factor that, and maybe I'm going to do it over here. So I'm going to show you how to do this one with the u. So if you've been wondering, even if you're comfortable with sines, I'm going to do this as a u. So my u is sine t. So I'm going to factor this. Two numbers that multiply to give me -6 and add to give me +1 would be +3 and -2. So then I'm going to decompose. So I've got 2u squared plus 3u minus 2u minus 3. Look for a greatest common factor. Out of the first group, I can take out a u to be left with 2u plus 3. Out of the second group, I can take a -1 to be left with 2u plus 3. My greatest common factor is now 2u plus 3, and I'm left with u minus 1. Now, when I write this back into my fraction, I'm going to replace the u's with signs. So this would be 2 sine t plus 3, and then the second bracket would be sine t minus 1. All right, well, what about the bottom? Well, in the bottom, I have a 1 minus cos squared t, a Pythagorean identity, right? Sine squared t plus cos squared t equals 1. So if I were to subtract cos squared t from both sides, I would end up with 1 minus cos squared t equals sine squared t. So I'm going to write that down, sine squared t, replacing the 1 minus cos squared t, and I've got minus sine t. Okay, still nothing to simplify, but hopefully now you can see that the bottom can greatest common factor. So I still have 2 sine t plus 3 times sine t minus 1 all over, I'm going to greatest common factor out that sine t to be left with sine t minus 1. Phew, now I have something I can simplify. Sine t minus 1 divided by the factor sine t minus 1 is 1. And what am I left with? I'm left with 2 sine t plus 3 divided by sine t. Do not be tempted to simplify. That would be called cancelitis. It's a major disease, right? Everybody's like, oh, look at the sine t's. They're just going to go away. This sine t is part of 2 sine t plus 3. It's not a factor of your entire numerator. So it's not available to simplify unless you take all of 2 sine t plus 3. So this is fully simplified and done. All right, I fully hope that you'll now go and do the quick check. So before we add on more layers, make sure that you're okay doing some of these questions on your own.